So 11 o'clock and time for chai and wine. Before I formally introduce today's speaker, and I think he doesn't need introduction. Just a small announcement again. 28th Feb, India celebrates National Science Day. So TIFR will be open for.
It's on a Saturday this year, very convenient.
Yeah, very convenient, and TIFR will be open for visits on that day. Please visit our webpage for program details and registration, etc.
Registration, if you want to see labs, is sort of necessary. You can walk in and come, but if you want to visit labs, then it's better to register.
And now about today's session. And today happens to be Galileo's birthday, and that is why you see today's title, and that we are going to discuss about Galileo beyond what he is commonly known. To tell us about that is Professor Arnab Bhattacharya. Arnab, along with heading TIFR's public outreach initiative, he also is a director at Homi Bhabha Centre for Science Education, and also a very active researcher in semiconductor optoelectronics. So with this,
and also somebody who reads about a little bit of the history of science. So online audience, I hope you can hear me. The only way we can check is through comments on the YouTube chat. So if you have questions and comments, please put them on the YouTube chat. And with this, I shall start sharing the screen so that you can see what is happening. So let me share my screen. Wait, I need to get this out of the way. Okay, so audience, here you can see the screen, and online audience, can you please confirm that you can see the screen and you can hear me? If you are watching, please put it in the chat. So as Ulhas has said, 15th February is the birthday of somebody I think you have heard of, Galileo or Galileo Galilei. Have you heard of Galileo? Yes? Okay, good. So in the talk, of course, Galileo lived from 1564 onwards, so more than 400 years ago. There are a lot of old paintings, etc. So you'll see some old paintings as well. But let me go on. Okay. So remember, the talk title today is the Other Galileo. Okay. So now Galileo is, of course, very, very well known. So let me ask you, or if you're online, you can put it on the chat. When you think of Galileo, what do you think of? What is the first thing that comes to your mind?
Telescope.
Telescope. And you can see this picture of Galileo. Picture of Galileo in Wikipedia shows he's holding a telescope. And observational, if you go to the Wikipedia page, what is he known for? So he's holding a telescope over here in his hand, and you can see he's known for observational astronomy is the first thing. Anything else? Dropping of the weights. So then there is kinematics, analytical dynamics, etc. Okay, but I want to tell you that there is a lot more to Galileo than dropping weights and astronomy. In particular, he made a lot of instruments. He provided insights into many aspects of science, and literally the birth of experimental science is thanks to Galileo. So yes, of course, telescopes and dropping things, all that, we will take a very brief look at it. But today's focus is going to be on the other things that Galileo did, because he did a lot of stuff. Okay, so first thing I must say that these are some randomly chosen things. I cannot cover everything that Galileo did, and I'm not a science historian. I'm just a storyteller, and there are lots of very good online resources. In particular, there is the Museo Galileo in Florence, and they have a very good website which lists a lot of things that are there, and all their collections and artifacts you can see. And I have liberally stolen pictures from there. There are also many friends I should thank, including Kailash, who gave me a very nice book, which I have with me, and I'll show you the picture of it as well. And let's start. Are you monitoring YouTube? Okay. If you're here for chai and wai, please come in. Oh, they're not for chai and wai, but if you're here for chai and wai, please come. So Galileo's most famous work obviously is in astronomy, as you said, and he wrote this treatise or this book called Sidereus Nuncius, which is translated as the Starry Messenger. And this is the translation till here. This is the Starry Messenger revealing great, unusual, and remarkable spectacles, opening these to the consideration of every man, especially of philosophers and astronomers. This is by, as observed by Galileo Galilei, a gentleman of Florence, professor of mathematics at the University of Padua. So in Padua Gymnasio, he's in the mathematics thing. And with the aid of the telescope that he's invented, what has he seen? He has seen the surface of the moon, innumerable stars, nebulae, above all 4 planets, revolving around Jupiter at distance, and which he has no one has seen before. And he says that they should be called the Medicean stars. Now, he was in the court of the ruler of Florence, the Medici family, and the Medici family sort of, he wanted to honor them. There were 4 brothers, so he said, okay, we'll name the 4 things. He thought they were things. So now we know that these are the Galilean satellites of Jupiter. That's what we call them today. So he found all of this. So this is his part on the telescope. And this work, Sidereus Nuncius, is the first published work on astronomy through a telescope. Okay, so this is part of Galileo that you are familiar with. And in this book, so this is one page of it, observations. This is sidereal or starry observations. This is his notebook. This is Jupiter, and this is, at some time you can see only 2 of the moons. Sometimes you see 2 on this side, 1 on that side. Sometimes you see 3 on this side, none on the other. Sometimes you see all 4. So he's made drawings of the moons. He has written about it in this thing as well, on the oriental side and the occidental side, east and west. What are the drawings of the moons he has seen? So Sidereus Nuncius is one of the first real records of astronomy, right? The other thing he is known for is mechanics, as most people think that he dropped balls from the Tower of Pisa to prove Aristotle was wrong. Okay, but this is most likely a thought experiment. It's not sure that Galileo actually did this experiment. What he definitely did was he slowed down gravity. It's very difficult to do experiments when you're dropping things. It's very easy to slow down gravity. All you need is an inclined plane. If you have an inclined plane and you roll things down inclined planes, you still have the effect of gravity, but you can study it over a longer distance. So Galileo used inclined planes. Also, Galileo studied the pendulum, the most famous pendulum being this one. This is the church, the main cathedral of Pisa, and in this is hanging a long chandelier. He observed this chandelier used to oscillate, and he timed it. There's no watches. He timed it with his pulse. He used his pulse to time this, and he found the relationship between time and period, time period and length and whatever else. He did a lot of work with pendulums. Okay, so this is what it is. And of course, this experiment of dropping a feather and a heavy object was actually done on the moon. You can see the video of this. Apollo 15, he drops a hammer and a feather on the surface of the moon where there is no atmosphere, and they fall at the same time. This is there. But by the way, Galileo was not the first to get this idea that Aristotle is wrong and drop objects. That is actually the Delft Tower experiment in 1586. Okay, Galileo is born 1564. Galileo does these experiments or whatever else around the 1600s. But in 1586, there were 2 Dutch or Flemish in those days physicists who had dropped balls from the Delft Tower. There is a tower of a cathedral in Delft from which they are dropped it. If you're coming for chai and why, please come. Please come. So this is the Galileo that we know, who worked in astronomy, and who worked in this mechanics. Okay. And there are lots of books, beautiful books about Galileo's life. So there is, of course, please come. There is, of course, Starry Messenger, taken from the work Sidereus Nuncius, which is a biography of Galileo. But I think the books which are probably the most, I would say powerful records are this book called Galileo's Daughter and Letters from Galileo's Daughter to Galileo, the exchange of letters. So this is very, very interesting. These letters are amazing. I have the book with me. This has been all translated into English. Now remember, Galileo is getting into trouble because he is challenging the church. Okay. Galileo's daughter, Virginia Galileo, has become a nun. She has joined the church. And so now she is called Sister Maria Celeste. Sister Maria Celeste is in an abbey, and Galileo and she write to each other. These are letters. And, you know, she is also very scientifically minded. She is not just giving him emotional support, but helping him with his experiments. She does some small experiments in biology and, you know, mechanics and all. She even does them in her abbey, but she copies manuscripts, she something. And I've just got two quotes, right? She is aware that my father is challenging the church where I am a member of. And every time she says she's trying to reconcile what Galileo thinks and what the church thinks. So now is the time to avail yourself more than ever of the prudence which the Lord has granted you, bearing these blows with that strength of spirit, with your religion, your profession, and your age require. She is telling him that don't worry, right? You must not make too much of these storms. Take hope that they will soon subside. She knows that he is in trouble after the Inquisition, right? And she says, if we could look into a giant telescope, one that sees much farther than this one, that is a telescope he has made, we might see a time when such things, that the acceptance of truth is possible. Okay, so despite being a nun in a church, she is trying her best to support her father. Okay, and these letters are just beautiful letters. Anyway, not just Galileo's daughter, lot of people have thought that Galileo did. So Einstein wrote a very important manuscript, a paper on the method of theoretical physics in 1933. You can read the paper, it's in Philosophy of Science. And he criticizes Aristotle, saying that pure logical thinking can give us no knowledge whatsoever of the world of experience. All knowledge about reality begins with experience and terminates in it. That is what he says. And then he goes on, it is because he recognizes he is Galileo, and especially because he impressed upon it to the scientific world, that Galileo became the father of modern physics, and in fact of the whole of modern natural science. So Einstein considers Galileo to be the father of physics and the father of modern science. Okay, and I think that coming from Einstein obviously is something. Now Galileo, what did he think? What is his views of the world? So Galileo approaches natural philosophy, Philosophia Naturalis. Remember, in those days, there are no plastic chairs and, you know, artificial materials and everything. The world is what nature has given us. And hence, the study of the world is natural philosophy. Okay. He believed that nature is the work of God, because he has to still reconcile himself with the church, and only needed a correct interpretive approach to be fully understood. He said that past scholars did not have the correct approach in basing their understanding on reading Aristotle's books. Aristotle is just you think about something and do it. You don't have to do experiment. Okay. The correct interpretation of a natural fact should stem from direct, close observations and from well-planned and carefully performed experiments to verify it. Okay. And then he says that a true scientist should be able to work out the collected evidence in lingua mathematica. And this is another thing you will notice. Galileo does not write in Latin. Galileo writes in Italian. He wants to communicate to the public. He wants to get people, please read what I'm talking. He is not writing in Latin. And what does he write? In the language of mathematics, the characters of which you can figure this out. The characteri are triangoli, circles, and other figures, geometric, right? Without these, it is impossible for a man to understand a word. Without them, it is like roaming in vain through a dark maze. Okay, so that's what he is saying. An obscure labyrinth. You can make out some of the Italian. Okay, so Galileo is saying that you must observe, you must do experiments, and the language of science is going to be the language of mathematics. And these three things are immensely powerful, and they sort of begin the Renaissance in science, modern science, in the West at least. So today's plan is to tell you some stories of a polymath, which will include instruments, insights, and the birth of experimental science, as we've just seen. So let's start. Please ask me, please stop me and ask me. If you're on YouTube, please put your comments in the chat. We'll try and take them. Haan, bolo. Lingua mathematica. What is lingua mathematica? Very good. Lingua mathematica is the language of mathematics. Okay. So Galileo says that mathematics is the language with which we can understand science. Haan, bolo. A polymath is a person who is good in many things, not just somebody who's good in physics or chemistry or biology or music or arts or something like that. A polymath is a person who is good in many different fields. So Galileo is good in astronomy, making telescopes, but he's also making microscopes. He's also making other things. He's helping the army transport water. He's helping build compasses. He's doing many things. Okay. Polymaths are very rare today, but earlier there were many people who used to excel in multiple fields. Okay, go ahead. You had a question. Yes, please. Why is mathematics the language of science? Is that what your question is? We'll come to that. Okay. So, see, if I have to find out in science when I do experiments, okay, let me ask you, what is an experiment? An experiment is something where there is something I want to understand and I poke it in some way. I change some parameter. I change something and I see what has happened. Okay. I am trying to make chai in the morning. I try to see if I boil the water quickly. If I boil it with the gas on low heat, I take 5 minutes to boil the water. I take 3 minutes to boil the water. Does something change? Will the taste of my chai change? If I add the milk first and then the chai, or add the tea decoction and then the milk, will the taste change? These are experiments. Okay. Now here, the way you evaluated the experiment was taste. But in most of the experiments that we do in labs and the modern experiments we do, we try and make some measurements. We measure numbers, we measure temperatures, we measure something. And then we use maths to understand it. So in today's world, most of the science we do, starting from Galileo's time, tries to understand science through the language of mathematics and equations. And when you grow up, you will also figure out that if I want to find out, if I throw something, after some time, how far is it gone, with what speed it is traveling, I need some maths to answer that. And that's why it's called the language of mathematics. Haan, bolo. Insights. Insights is, I want to know something about it. Some deep knowledge of something is an insight. Okay, I'll come to it. You'll see. So, shall we begin? Okay, any questions on YouTube? Nothing so far. Good. So, the first thing he made, his first paper, this is his at age 22, Galileo's first work before any of the astronomy and the dropping of balls and all that happens is the hydrostatic balance. Okay. And this is his first paper, La Bilancetta, a small balance. Okay. And what does he say? This is by Signore Galileo Galilei. He agrees. He starts off by saying this is a copy of the problem that Archimedes had about a crown. Archimedes' problem of the crown, in which there are proportions of different metals that are mixed. So he knows Archimedes is not 2000 years before this, right? Archimedes has done this thing. Archimedes is a story where he goes to then jumps out of the bathtub or something and he finds out that something else. But Galileo is now going to make a balance. So he makes a balance, which is, I mean, this is from the Museo Galileo. He designs it very carefully, and he has drawings and what are the different distances, how will you measure it, where do you put it in water. He has the rider. He has a very small piece of wire that he can put on one balance arm to make very small measurements and check it. Unfortunately for historians and everybody else, this is forgotten. Why? Because he wrote it in Italian and not in Latin. In those days, all serious scientific work is done in Latin. This guy writes it in Italian. And hence, the serious scientists of the day miss this. And historians miss this. And then they said, oh, but the idea to Archimedes ka hai. There's nothing new in this. Where's the data? But then people have found, and it is found only in 1879. When they went through all the papers, the appendices of this, he has a table of proportionals of the proportion of the specific gravity of the metals and gems in air and in water. He has a table of specific gravity, a table of density. What you do in these things, if you have silver mixed with gold, which was the problem, you will actually dip it in water and see how much water is displaced, find the density of it. And he actually has a table of densities. He had the data. It's just that it's an appendix to the paper. The paper is in Italian and not in Latin. In those days, you didn't write in Latin, like Sanskrit nahi aata hai usko, So that's the equivalent, and this thing gets mixed. But he actually did a lot of work. The first work he did at the age of 22 is this hydrostatic balance. Let's move on. So next we will come to a compass. Okay. And a compass also has a very interesting story of a 17th century dispute about intellectual property. Okay. So Galileo is working on this compass. This is not a drawing compass. This is not a drawing wala compass. Okay. This is something called a proportional and military compass. It's an instrument which has two arms. There's another leg on the other side to make it stable. There is a plumb line to hold it so you know that it's vertical. There are scales on it, and you can move these out, in and out, these arms. There is another thing here which can slide up and down. This is also a predecessor to a slide rule, because by moving this, he can do some calculations. Okay, so and you can attach a quadrant to it, etc. Now this allows you to make measurements. It also allows you to find cube roots and do some mathematical calculations. So Galileo's compass is very useful. It's useful in the military, because if you want to calculate what angle should I have and how much gunpowder should I put to have a cannonball go to some distance, you need to make these calculations. This instrument helps you to do it. Okay, but Galileo is a very smart guy. Okay, and he builds this compass in 1597. 1597 is when Galileo has his compass. He publishes a manual on its use in 1606. It's called The Operation of the Compass, Geometric and Military. Okay, and he uses the Italian word compasso, which is compass. Okay, now the interesting thing is that next year there is another guy called Baldassare Capra, okay, who publishes in Latin. He publishes, so this is the Operation of the Compass, Geometrico and Military by Galileo Galilei, a nobleman of Florence. Okay, and he, of course, he's always grateful to the Medici brothers, because they are the ones who are sort of his sponsors. Now this guy in 1607 writes in Latin about the fabrication of a circina. Circinus is also compass. Okay, if you're interested in astronomy, there are two constellations, as Circinus and Pyxis. Both are compasses. Circinus is a drawing compass. Pyxis is the north-south wala compass. Okay, and the word Circinus is this compass, because from this you can draw circles. Circinus is the Latin word. So he's got this in something. Now Galileo said, "Arey yaar, ye to mera kaam hai." Okay, because this apparently is a translation of this. So he decides that I will challenge this guy, and he goes to the university in Padova, okay, and he says that this guy has copied my work, and there is an inquiry. In the inquiry, this guy finally admits that मैंने copy किया है. He wants to say, मैं sorry बोलता हूँ, I will write an apology, let us forget it. But Galileo is smart. He doesn't agree. He insists that there is a hearing, and he is accused and found guilty of plagiarism, and orders the court. They order that all copies of this book must be burnt. So he wins this court case. Right? So this is one of the earliest documented court cases of an intellectual property dispute in the 16th century. This is happening around 1610. But by the way, just an aside, this is not the first IP dispute. The first IP dispute is much more gory. This happens in the 6th century. There is the Saint Columba and Saint Finian dispute, because somebody had a book of Psalms. The other guy copied it. The guy said, "Nahi bhai, tu mera book copy kar raha hai." He said, no, the work of God is to popularize it and spread it, and hence I am copying it. Right? the guy whose original book it was wins the argument, but the other guy says nothing doing, I don't agree. So they get their armies out and fight, and 3,000 people die as a result of this in Ireland. Okay, so fighting about IP is not new. Okay, let's get back to this. But Galileo is a very smart guy. A very smart guy. This is the first example of branding. So Galileo's compass is very useful. You can use it to calculate the Cannon angles. You can use it to do other proportional measurements, compound interest calculations, cube root finding, etc. He's made one. Now you have to make it and sell. So he contacts this guy called Marc Antonio Mazzoleni, and he produces this. Okay, he produces hundreds of them, which he sells. In those days, he sells these for 50 lire, the currency in Italy, along with the manual. But he's very smart. His manual leaves out the key details. You cannot read the manual and figure out how to use it. So what does he do? Those who want to learn how to use the compass have to pay for private lessons, not at 50 lire, at 120 lire. And he has a side job that makes 3 times more money than he's making as a university professor. Okay? Yes, please. Sorry. Artillery men are people who man cannons and guns. They are the people who fire guns. In the army, the artillery is the people who fire guns. If you're firing a gun, in those days you have to put gunpowder in it. These days it's all automatic and you just put something and you press a button and it fires. There's some computer that calculates at what angle should I hold the gun and all this. But in those days they had to do it manually to fire a gun. And you have to calculate what is the angle, and this device used. And in those days, I think they made them very beautifully. I mean, it's very nice. See these old pictures. This is actually the Harvard Museum. I've seen this thing. So that's what it is. Yes, please. He's a good businessman. Why did he take 50 for the instrument and 120 for the lessons how to use it? He is a good businessman. This is the standard strategy today. They will give you a free SIM card and make you pay monthly fees to use it. Right? Same principle 400 years ago. He's giving you an instrument for cheap and a manual, but the manual doesn't tell you very much. If you want to use it, you have to pay me and learn, take tuitions from me on how to use it. Though tuition costs more money. Okay, so he's a good business branding. Galileo is way more smart than just making telescopes and dropping balls. He knows how to do business. Okay, go on. All right. You guys are enjoying this? Okay, good. Then the next thing Galileo makes is the thermoscope. This is an early predecessor. This is 1592 to a thermometer. Okay, what is it? It's a glass tube with air and a little bulb there. And there is a larger thing here. If there is liquid in this column, if this air expands and contracts, can you go cool this guy, please? If the air expands, the density, the temperature changes, the density will change, and hence the air will move up and down, and the liquid will move up and down, and you can get an idea of the temperature. Okay, this is a thermoscope. The problem is there is no scale on it. Modern thermometers have a scale. Okay, but this is at least the first thing where you can actually measure temperatures in quantifiable manner, and this forms the basis of other thermometers. Yes, please. Yes, when Galileo made the thermometer, what happened? No, it's not the modern thermometer, but this is the basis for the modern thermometer. The idea that I can use expansion of a liquid. What does the modern thermometer do? Let's say a mercury thermometer, or a thermometer which has a long tube in which there is some colored liquid. The liquid expands. There's a scale. We can measure how much it's expanding, and we can figure out the temperature. That's how a modern thermometer looks like. Okay, this here, the air is expanding, density is changing, and this thing. Now tell me this. Go back 400 years ago. Okay. Why is knowing temperature important? Let me ask you this. If you're on Zoom, please put it in the chat. Why do you think in Galileo's time it is important to measure temperature? To purify water, okay. Yes. For what? The hydrostatic balance. For that, I mean, yes, I mean, you should know the temperature of the water, but I mean, it's not going to be that critical. Any other reasons? Why do you think Galileo's time measuring temperature is a big problem? There is no quantifiable way of measuring temperature. Okay, let me just show you this. I'll just skip this. By the way, today, Google Galileo thermometer, you will get this. Okay, this is what is called a Galileo thermometer. Okay, this is a very interesting object. The principle is that of Galileo's. Okay, but Galileo did not invent this at all. The first device like this is actually almost 100 years later after his birth. In 1666, one of his students, whom you probably know, Torricelli, the barometer guy, they invented something which is like this. Now, what this has, this is called a slow thermometer. Okay, this has a tube containing a liquid. This liquid is a alcohol water mixture. In this are different things that can float or sink. Okay, and right now all these are sunk. This is floating. This has 28 on it. That's the temperature. Just remember that the lighter the object, so as the temperature of this liquid will increase, its density will decrease, and a lighter object will float, a heavier object will sink. So these objects are carefully made to float or sink at a certain temperature. So right now, room temperature is about 28. This guy is floating. I hope you've got cold water, but you've not got much cold water. Somebody turned off the cooler. Very bad. Okay, we'll try and cool this guy and see what happens. Okay. So the point is, this guy was invented in 1990s as a souvenir from London's Natural History Museum or Science Museum, but it looks cool, as you can see. I mean, it's a nice thing to have on your desk. It looks very cool. So the physics principle is similar, but calling it a Galileo thermometer is just marketing. Okay. But let me get back while we cool this. Let me get back to why is knowing temperature matters. Because there are many reasons. See, earlier, temperature is a subjective thing. Physicians would measure pulse and believe that pulse rate changes with temperature. Cooks would have some sense for it. Okay, 10 minute rakho, patata ho jata hai, whatever it is. Now, Galileo's colleague, Santorio, is a doctor. He uses it from 1611 clinically to measure body temperature variations during fever, digestion, and sleep. And he first writes this thing about in Italian again. Okay, now you see that after cooling it for some, 26 has also gone up. Okay, and 20, you can see earlier all of these were down. Now they are getting separated. 24 is coming up. Cool it. 24 upar jayega. Okay, now in 1614, there's already a book that's coming out, the Medicine Static, okay, which is thermometer readings versus body weight changes. So people are trying to do research on temperature. By the way, please realize Galileo prints his books. Huh? The printing press has already been invented. People will do whatever they write. Why body weight? We don't know. Yes. The thermometer measures body temperature. When you get fever, they put a thermometer like this, no? Or they these days put it in your mouth or your ear or something like that. So it measures, the thermometer measures your body temperature. If you have fever, if you have some infection or something, the body wants to make it hard for whoever has, the body works best at 37 degrees C. 37 C is, now you can see 24 has gone up. 24 has gone up. The air, that thermoscope, that, I mean, you do this at home. Take a straw, fill it with water, put it in some jar, and put it through a cork or something. You warm it with your hands. That thing will go up and down. It's very sensitive. It's very sensitive. All it needed was a scale, which somebody probably figured out how to put. There must have been a range. I don't know. Anyway, then, so one thing is medicine. The other thing is this starts measurements of weather. Okay. There is one of his friends, Sagredo, starts measuring the temperature in Padua daily. You're getting weather reports now. Then Galileo used to work with industry. He used to work with glass makers. And right near there is Venice, where you have Murano, which is very famous for glassware, crystalware. So their temperatures in the furnace need to be standardized. So they needed a thermometer. Okay. Then if you're making metals for bells or for cannons, all that for casting, you need to know the temperature. Okay. If you're making wine, very important in Italy, you need to know the temperature of the yeast to ferment carefully. Okay. And then, of course, in chemistry, as somebody said, distillation. If you have to heat water and get it somewhere else, if you want to separate essences from flowers and all this thing, make medical thing, you need to know temperature. So knowing temperature is very important in those days. And now you have, thanks to the thermoscope with a scale, you have a thermometer. So the invention of the thermometer is actually a very important step in allowing us to do a lot of things. Okay. And yeah, I was just saying that there's a book, right? It's printed. Remember that the invention of the printing press actually makes science available to a large number of people. Otherwise, you have to write by hand. Okay. Ask me later about what are the things that were essential for the printing press to be made. The ingredients that are essential for the printing press actually are quite surprising. Anyway. So you've seen this decorative thermometer. Is it still inside? You can take it out and we'll see as it warms up what happens to it. Okay, now this is cool. And now it is 22 is probably the one in the floating. In the middle is 22. We will keep it and you will see how these all slowly sink as the temperature will go up. It's a very slow thermometer, as I said. It's called a slow thermometer in Italian. Okay. So now from the telescope, you go to the other side, the microscope. Now, if you use lenses which have a short focal length is if I shine a light, where does a spot be formed? If I have a magnifying glass, you shine light, there'll be a spot somewhere. That distance is the focal length. He turned the telescope around to magnify things. Now, his first microscopes were made in 1609, which were the same design of his telescope, 2 lenses. Eventually, by 1624, he had developed something called an occhiolino. The word microscope has not yet been known. Okay, this is a copy of it, which has 3 lenses and a magnification about 30 times. And it's only in 1610 that one of his fellow Academy members, Giovanni Faber, coins the word micro and scope. Micro for small and scope for something to see. He calls Galileo's invention a microscope. So Leeuwenhoek, who invents the microscope, actually in the Netherlands, Antonio von Leeuwenhoek, he didn't call it a microscope. The microscope name is given to Galileo's design in 1610. Okay, so he also sort of played with the microscope and looked at the small world and not just the world of stars and planets. Okay, so this is Galileo with the microscope. Now, what he probably didn't do, there are many things which says that Galileo invented what is called the caged ball bearing. Now, ball bearings have been around. Using balls, something is very heavy, to move it, we will put some spheres and make it easy to roll by putting balls, is around. But those keep slipping away and everything. The big thing in ball bearings, any modern ball bearing looks like this. Okay, this is called a caged ball bearing because the balls are within 2 little cylinders kind of thing, right? 2 discs or with hollow, So this idea, actually, I don't think Galileo, looking at whatever I have read, I think Galileo did not. There are many sites which say Galileo came up with this idea, but it's more likely this drawing is from Leonardo da Vinci, who predates Galileo, right? Who says that you should enclose the balls within some, some kind of a cage. So the idea of the ball, but when Galileo did know about this, certainly, and Galileo used a lot of his ideas to make the first pendulum-driven clock. See, measuring time is very, very important. In those days, people are trying to measure time more and more accurately. First it is pulse, then it is other things. The pendulum swings with the pendulum. You need something called the escapement mechanism. The escapement mechanism, this is Galileo's design for it. So, the accuracy of clocks, because especially if you are going on a sailing trip far away and you need to know your position by the stars, etc., you need to know the local time. And the only way you need to know local time is you need a chronometer which you can sync with where you left. What is the time? And that becomes that is, there are many awards given for finding time. Okay, anyway, now the next big thing Galileo did, by the way, you can see 22 has now gone down. As it's heating up, 22 has gone down. After a while, you'll find this 24 also will have gone down as it slowly heats up, because it's warmer than 24 over here. So Galileo's final work is this thing called discorsi, which is a discourse or a dialogue concerning the new sciences. Okay, and it's also a mathematical demonstration. And in this, so this, by the way, he is now, poor guy has had taken panga with the church. He's not allowed to publish anything in Italy. It's published in the Netherlands. It's published in Leiden. So this is in Leida, okay, because this you can MD. This is basically 1638. 1638 it's published in Netherlands because he's not allowed to publish in Italy. And this is written as a dialogue between three people. There is Galileo. Salviati is effectively Galileo. There is Sagredo, who is some layman, and there is a Simplicio, who is an old-style Aristotelian guy. Okay, so they are having a dialogue on day 1, day 2, day 3. They keep discussing things, and the book is divided into day 1, day 2, day 3, etc. And it covers what makes material strong and how does it scale when I change the size of something. And this is the first mathematical treatment of how size affects structures and how strong structures are. Okay, that is this book, 1638. And in this, Galileo starts with everyday observations that says that, look, things are not invariant with scale. So he says, look, a small dog will survive a fall that will kill a horse. Or a grasshopper falls from a height unharmed, but a human, if he falls from that height, would die. So clearly there is something different with size. Okay. And then he takes the example, he starts with just simple cylinders. Okay. And says, I am going to approximate bones and limbs to be cylinders. And so what happens if I increase the size and make something 10 times taller? If you make it 10 times taller, then the volume goes up by a factor of the length cubed. So the volume and the weight of it will become 1,000 times that. But the area of it will go as squared. The area of it will only go as a k squared, whereas the weight of it will go as k cubed. As a result, your bones will become too weak if you just scale them and your weight increases. Which is why larger animals have much thicker bones. Elephant legs are thicker than a mouse's legs, is what he says. Okay, so these are the beginnings of scaling theory. And then this is his most famous diagram of the bone and a scaled up bone. And what he says here is, I have sketched a bone whose natural length has been increased 3 times and whose thickness has been multiplied until, for a correspondingly large animal, it would perform the same function which the small bone performs for its small animal. Okay. Clearly then, if one wishes to maintain in a great giant the same proportion of limb as that found in an ordinary man, he must either find a harder and stronger material for making the bones, or he must admit a diminution, smaller thing, of strength in comparison with men of medium stature. Otherwise, a giant would be crushed under his own weight. He outlines why giants cannot exist. Giants cannot exist because if you scale somebody too large, they will get crushed, their bones would get crushed by their own weight, because weight scales as cube, area scales as square. So unless you make much fatter bones, it won't work. Okay, this is 1638 Galileo. Okay, very simple argument. Today it's simple, but in those days, these were radical arguments. Okay, all of this thing is available. All of these things are available. So Galileo changes the way people think about science and about experiments. So before Galileo, it is authority, right? Even during the time of Galileo, it's the church. So Aristotle said heavy objects fall faster. Everybody believed it for 2000 years. Aristotle ne bola hai bhai. Okay. Now Galileo says, let's test it. Let's do experiments. So the shift happens from what somebody big says to what does the experiment show. So Galileo, what he outlined in his approach were 4 things. You first must observe and notice patterns in nature. Then you must measure, you must quantify this with instruments. Finally, you must find mathematical laws like things scaling as square or cube or something. And then predict and test, design experiments to verify what you have got. This is basically what is modern science today. Galileo, what he says was his approach is what is modern science today. Okay. Yeah, if you have questions, you can please ask me. I don't know if there's anybody monitoring that, but anyway. Finally, I'll just come to you. I have just 2 more slides, so let me just finish. Finally, in 1992, Pope John Paul II acknowledged that the Inquisition had made a mistake in condemning Galileo for asserting that the Earth goes around the sun. In 1992. And John Paul said that the theologians who condemned Galileo did not recognize a formal distinction between the Bible and its interpretation. So the church forgives Galileo in 1992. A bit too late. Actually, in December 2008, during events to mark the 400th anniversary of Galileo's earliest telescope observations, at that time it's Pope Benedict. Pope Benedict praises his contribution to astronomy. Pope Benedict promised that they would build a statue of Galileo in the Vatican, but that has not happened up till now. Okay, so the church finally relents and forgives Galileo. Now, this is the last slide. So, Galileo didn't discover facts. He showed us how to discover. Okay, and the fact that you need tools, you need instruments. Instruments are important, telescope, microscope, thermometer, whatever it is, balance, something. So next time somebody mentions Galileo and telescopes, which is how we started, please remember he also weighed gold, he measured heat, he saw insects' eyes in a microscope, he explained why elephants have thick legs, and he gave us the experimental methods. So once again, happy birthday, Galileo. And I'll end with this picture. This is a picture by a very famous painter. This is Rubens, okay, Peter Paul Rubens. This is a self-portrait. This is Galileo, right? This is Galileo. This is called self-portrait in a circle of friends from Mantua. The reason this is interesting scientifically is if you look at this painting at the back. So this is Mantua, and they have identified some of these things. At the back, these lights in the sky. These are the Aurora Borealis, the northern lights. And Galileo gave this term in 1619 to describe the thing. He named them to Aurora, the goddess of dawn, and Boreas, the Greek god of the north wind. Unfortunately, he made a mistake. He thought that this is sunlight reflecting in the atmosphere. He did not know how the aurora happened. But the term aurora comes from Galileo, and it's there in this painting by Rubens of Galileo, which shows the lights over here. So thank you very much. I'm happy to take questions. He had his hand up first, so let me take his question. I'll come to you. Okay. The question is political, he says. Okay.
Make it tougher to access by finances of it and modern scientific or ideas. It's tougher for common people to access science as well. So, I mean,
so clearly, Galileo decided to publish in Italian. Most of his work is published in Italian because he was interested that it should reach out to people at large. Also, the family that supported him, the Medici family in Florence, and he's a professor in Padova. Definitely, that's happening in Latin over there, the university. But there in Florence, he thinks he will get to more people if he writes in Italian. So he's writing in Italian. The only thing is, because he's writing in Italian, some of his work is probably missed by the people who know only Latin and will read only Latin. This is very similar to, a lot of the Russian literature in the sciences has been missed out because people focused only on the English. In physics, certainly that has happened. So that is there. Now, at one time, if you go to the early 1900s, many of the classic physics papers are in German. Before that, it might have been French. So right now the language of science is English. So obviously along with the times, the language that people use changes. People who are not publishing in the dominant language will be at a disadvantage. So yeah, this is part of life, I would say. The what?
Finances of
The finances.
accessing research is very difficult from different IPs, and then it hampers the progress of science.
Yes, I mean, it hampers the progress of science because it's locked up in something, and yeah, that is true. But see, Galileo also understood this very well, and as I showed you, he made money out of it. Okay, and he went after anybody who tried to copy his work. So he understood this game, I think, very well. So I think Galileo would have survived very happily today in the world of venture capital, finance, and all. Galileo would have figured out what to do. But anyway, I think the girl first, and then I'll come to others. Yes, go ahead. Why did the of theology? A theology is a person who studies religion. A theologist is a person who studies religion as a subject. Okay. So yeah, the boy there. I'll come to you. Yeah. You didn't understand the what? I can't hear you. Just be loud. Smaller animals would survive a fall and larger animals wouldn't. I'll come to that. I'll explain that. Why do smaller animals survive a fall and larger animals don't? Okay. Yes. How did he make himself? How did Rubens paint himself? He probably used a mirror. Yes. Mirrors were available. Mirrors have been around for thousands of years. Yes, sir, go ahead. The previous attempts to measure temperature, I really don't know. I don't know the accurate thing. Yes, go ahead. How does I'll explain the same thing about why do people fall. We'll just go through that again. Let me quickly check if there are any questions on YouTube because I don't know where. Okay. Okay, there's one question about how did. Okay, by the way, the folks who are here, you can see that now everything apart from 28 has gone down. So I had what is called a Galileo thermometer with me, where these things float up depending on the temperature. The cooler it is, more of them will float up. The one which is floating is the lowest one of the floating ones is the temperature of the liquid inside. So we had cooled it in water and made some of these go up, but right now it's at 28 over here. Okay. So one interesting question on YouTube is whether Galileo was aware of the work done in Arabia or in Africa or in Mesopotamia by many of the scholars at that time. I would think most likely yes, because there was a lot of crosstalk happening between civilizations at that time. So yes, I'm pretty sure he would have been aware of this work and would have used it. Of course, in the works of what did you say, Al-Kharazmi or something, I don't think we find exactly the same things which Galileo has done. They did have a lot of work on things which were local over there, petroleum, refining, distillation. There clearly they were way ahead of other people. But maybe in some of these things, Galileo was indeed. Of course, there may have been other people who did it and did not record it as clearly as Galileo did. So we may not know about them, and again, a lot of it may have just been lost in translation. But I am sure Galileo was aware of the work Renaissance Europe was aware of the work of what was happening in the Middle East very well, and Central Asia. Yes. Okay, let me just see if there are any other questions here. If not, we will stop this and. Okay. Okay.